our first section. This is a repeat. You had this on the last summative. You guys are going to get a new score. I don't plan on retesting this section, though, so make sure you do your best this next time. However, I think this time I put a couple challenging questions on there. For instance, number 1A, it says 3x minus 1 raised to the, does that say third power we decided? All right. So that does not mean distribute a third power to everything. That means you guys are going to multiply, yes, 3x minus 1 times 3x minus 1 times 3x minus 1. So when you simplify and FOIL this out, you have to do this in stages. So please start with the back two binomials, and we're going to FOIL 3x minus 1 times 3x minus 1. So it's still going to be in a set of parentheses, but we get 9x squared. And then I'm going to do the outer inner step at once. We have negative 3x plus another negative 3x. So that's going to give us negative 6x. And then 1 times 1 is positive 1. But we're not done. Because now we have a binomial times a trinomial. So you have to keep distributing. Start with the 3x and distribute it to everybody in that trinomial. And this is similar to a question you guys saw in the last summative. 27 x to the third, good. Minus, let's see, is that 18x squared? Plus 3x. And then in the last summative, when we had a binomial times a trinomial, some of you stopped here. But that's not the end of the problem, is it? Because we still have the negative 1 we have to distribute. And our suggestion is that when you distribute the negative 1 to the 9x squared and you get negative 9x squared, it would be smart if you wrote it underneath the other x squared term so you can simplify. So that's a plus 6x. And a minus 1. So finally, we end up with 27x to the third. Oh gosh, is that minus 27x squared plus 9x minus 1? All right. So some of you don't believe us when we tell you every other question on this review is the exact same style question. So if you don't need to practice that type of question anymore, please do not continue on and do 1B. That's just there if you need more practice, more help. Let's skip. Yes. I mean, yes, you can do it. Sorry if you feel that you're terrible at them. Good news. Pretty much your whole class was terrible at it last time, too. So, sorry. Revenue is the function 17x. And what are we selling this time? Oh, coffee mugs. Perfect. And then our cost function is 9.25x plus 400. And the first question is, what is the price of one mug? Meaning the money I take from my... It is 17. So you take the revenue function, because that's the money I take from my customer, and that's what tells me how much I'm charging the customer, $17 per mug. This is where y'all kind of botched it up last time. Profit. Profit is found by taking the revenue, the money you take from your customer, and then subtracting the cost function. So, codename, whatever. Help me set up this function. What's our revenue? Start there. Well, I kind of scribbled it all out, but here it says the revenue is given by the function right here, 17x. So that's the revenue, 17x. And then we're going to subtract the cost function, which later on they gave me this. Yes, but if I write it like this, I'm going to fall for the trap that a bunch of your classmates did last week. Because they're going to tell me this is a plus 400 on the back end of the function. But it's really going to be a minus 400 because they're going to distribute that subtraction. So what's 17x minus 9.25? Well, but if I simplify those, 17 minus 9.25? All right, so we get 7.75x. And then the most crucial part of this is not a plus 400 anymore. This is a minus 400. So there's the profit function. I don't mind if you just leave off the p of x at the beginning of it if you just write down the function. Now you're going to use that function and tell me the profit if I sell 2,000 mugs. So hopefully we did this part right, because now you're about to plug 2,000 in right there and tell me an answer. 15,000 and what? 100. All right. Big profit in selling coffee mugs. Should do that. All right. Right here. So we distributed the subtraction sign. We kind of skipped a step though. you could write 17x minus 9.25x minus 400. And then when you combine your like terms, the 17x minus 9.25x, you get 7.75x. The most crucial part of that, though, is that you use the parentheses and distribute the negative to the 400. Alrighty. So again, 2b is just like 2a. So if you don't feel like you need any more practice, leave it alone. If you feel like you want to save it for tonight when you're practicing by yourself, then great. This is new. This is a new topic. We don't have any scores for this. Now be careful. While I give you the same functions f and g in this section, I ask you to do different things. So the first question is f of negative 2 plus g of negative 2. So there's two methods. You can either add the two functions together and then plug in a 2, or you could plug in a 2 to each function and then add your answers together. So for most of you, you found it was easier to plug in a 2 to each function and then add the answers together. So if I plug in a 2 or evaluate this blue function at 2, you get 7, or negative 2, excuse me. 7 times negative 2, use parentheses, squared minus 5. Someone type that in for me. What does that come out to? Is it 23? All right, so this is 23. And then we're going to do the same thing for the green function. We're going to evaluate at a negative 2. So 7 times negative 2 minus 21 is something gross. Negative 14 minus 20 is negative 35, isn't it? Okay. And we're supposed to add these two answers together. So the final answer is negative 12. Okay. Here we go. That would have been the same answer had you come up with a new function where you added the functions together and then evaluated a negative 2. Were parentheses important when you plugged in a negative 2, especially into that blue function there? Yeah. All right, the next one, f minus g. You are asked to subtract the two functions. So we're going to run into the same problem that we ran into on the profit question, where some of us are not going to do this properly because of parentheses. So f of x is 7x squared minus 5. And then if I'm going to subtract g of x, I have to remember to use parentheses. Now, I don't think it's really worth it for you guys to do tons of work in your head on a summative test, because this is where mistakes happen. So I don't think it's going to kill you to write out an extra step here. This is a minus 7x, and this becomes a plus 21. What I would like you to do, however, is simplify as best you can. So the negative 5 and the plus 21 are going to combine together for a plus 16. So 7x squared minus 7x plus 16. Standard form answers are the best when given a choice. Okay, next one, f of 2 times g of 2. Again, you could multiply the functions together, get a new function. It's going to be really gross, by the way, because you got to FOIL a lot. And then you can plug in a 2, or we can do the reverse. We could plug in a 2, multiply the answers together. I think that's the easier way to go. So I'm running out of space. I'm going to do my work up here. F of 2. So plugging in a 2 into function f. Now it's 2 this time, not negative 2, so don't steal your answers from over here. So 7 times 2 squared minus 5. This does happen to give you the same 23. And then plugging in a 2 into g would give us 7 times 2 minus 21, which is negative 7. And then we're supposed to do what with these two answers? Multiply them together. So 23 times negative 7. My brain stopped working. I need some help on that. For reals, I need some help. Multiply. Like on a calculator. One more time. Negative 161. Thank you. All right. So my baby. The next question, you have to set up the division, which is not the hard part. That part should be pretty easy, actually. And then you have to tell me the domain restriction. So setting up the division should be easy. We just write 7x squared minus 5 in the numerator, divided by 7x minus 21. Now, please don't have the urge to simplify anything in the division question. Just leave the division like that. There are times when things do simplify, but we're not going to worry about that for now. The domain restriction is what I'm worried about. So remember, if you have a fraction, what is like the one thing you're not allowed to divide by? You can't divide by 0. So what you're going to do is you're going to figure out what happens when I set the denominator equal to 0. So you're going to say 7x minus 21, the denominator, cannot be 0. And you're still going to go through and solve. So add the 21. So 7x cannot be 21, which means x cannot be 3. This is your domain restriction, guys. Everything in the whole planet's good, just not 3. Sometimes you guys could easily tell me the domain restriction because it was a real basic denominator. Sometimes we had to do a little algebra like there. And I'm super out of room here, so I'm going to rewrite f of g of 2 down at the bottom of my screen. This is called composition. You're going to put a number into a function, and then you're going to get an answer, and then take that answer and go into the previous function. So where do you start? Because it does make a difference. In the middle. So you start with g evaluated at 2. So let's figure out what happens when I plug a 2 in for g. I think we already did this earlier in the question set, but whatever. 7 times 2 minus 21 is negative 7, I'm hearing. All right. So this number is really this. So the problem now says find f of negative 7. So go back to function f this time, and you're going to plug in a negative 7. And I definitely need a calculator, guys, because I have no idea what that is. Yes. Not that I didn't trust you, but 338, thank you. Does it matter that we went g of 2 first? What if I went f of 2? That'd be wrong, so don't do that. Alright, that is new. I would suggest you guys spend some time trying the secondary problem to that section on your own later. Let's look at 4a. Old stuff. Coming back. You're going to get a new score. So first few questions are vocab. Here's your function. And I'm going to ask you who the lead coefficient is. So I just do a triple check that it's in standard form, which it is, and then I heard the lead coefficient is a negative 3. It's the lead off term's coefficient. So now I want to know the degree. Good, the degree is 2. It's the highest exponent that you see. Now, don't fail me on this one, guys. We spent a whole month on this particular function back in November. It's the quadratic, yes. Degree 2 is a quadratic. Cubic. Quartic. All right. Degree 6. That'd be an easy one. There's no name for that one. They were like, no more names. Now I want you to plug in or evaluate the function at negative 5. So you're going to take your function in your home screen, negative 3. Make sure you use parentheses, negative 5 squared plus 14 times negative 5 plus 9. You can store it, absolutely. Some of you guys like to store. So you type the negative 5 and then stow x. And then you just type in the function. You don't have to use parentheses. And I just made this problem up, so I'm sure the answer is weird. Ah, of course. So now I want to sketch. You guys have a graphing utility, so go ahead and hit graph. If you have a weird window, try Zoom 6. See if you can see what you need to see. I don't know if we can, though. Do we have to adjust our window? I hope. This would be a good experience for us. If you're in the standard window, can you see the top of the parabola? You guys are typing the function into y equals. Oh, good. What a good experience for us adjusting our windows. You actually don't have to adjust the window to find the max, but I think it's a good practice thing for us here. So, that's not what we want. All right, negative 3x squared. I already forgot the function. What's the rest of it? Plus 14x. Plus 9, thank you. So if I hit zoom 6, I technically can't see the top of the parabola. Because of our knowledge of parabolas, we kind of know what it does, but if I want to adjust my window, who would have to go to a larger number so I can see the top?
30.
The Y maximum, and then I'm hearing 30 is a good choice. All right, I'll go with that. Some of you like the zoom out method. That works. It zooms everything out. And I don't think we needed to zoom the X's out in any way. All right, there we go. So now I'm going to be asked to find end behavior, domain, and range. So while we have the screen open, can you guys help me find the maximum value of this parabola? So second trace, and that was a maximum. Then you guys are tracing left and right. I have to hop left and right because of the lag. So left bound, sure. Right bound, let's go 4. And then when it says guess, just make sure your lines match up. So which value here is going to be affecting one of our intervals for domain or range? The Y value, and it's going to be the top of our range. So 25.3, remember that. So I just heard the range. Oops. Oh yeah, lovely. The range stopped at 25.3, which means it started at negative infinity and went up to 25.3. Last time you guys tested this, some of you just gave me a really rough estimate for the top of the range. Like you were rounding way too much. So at least give me a 10th spot. If you round to the whole number, that's because it rounds to the whole number, and that's not what's happening here. What's the domain of this, or frankly any polynomial we ran into? Yes, negative infinity to infinity. Very good. All right, let's talk about end behavior. X goes to negative infinity. It's fancy talk for left. So what is your end going to? Negative infinity. Good. And then X goes to positive infinity is fancy talk for right. Where's your end going? Negative infinity. Basically, you're saying down and down. All right, so if you need help with those, or at least if there's a certain part of those questions that bothers you, I would suggest moving on to 4B before you leave here today with a graphing calculator. Hey, what's the degree on 4B, by the way? It's 4, so it's a quartic. Thank you. Oh, that's new. Got your factoring flowchart out?
You.
That's not right.
I don't like factoring.
Well, factoring,
Especially this factoring.
maybe factoring's not a real big fan of you. All right, get your flowchart out.
Huh? You're loading.
Flowchart. All right, top of the flowchart, guys. What's the first layer of the flowchart all the time? Common factor. So when I look at 5A, is there a common factor? Nah. So move down the flowchart. There's no common factor. Move down the flowchart, and I see two terms. So be on the correct spot of the flowchart. We're looking at two-term patterns. Now, dead giveaway, guys. It has a plus sign. There's only one pattern in that box that has a plus sign in the factoring. This is the sum of two cubes. So the pattern that we're going to be factoring into is a plus b times a squared minus ab plus b squared. Just pull that straight off the flowchart, which you can use on your test. If only you could figure out who a and b were. So you got to go backwards. If this is a to the third power, what is just a? Good, x. And then go backwards. If this is b to the third power, what is just b? A 6. Very good. It's the cube root of 216, which you can either count on your perfect cubic box, or you could second or math and then go down to number 4, I think. So now you just fill them in. So a plus b would be x plus 6. A squared is x squared minus 6 times x. And at the end, 6 squared, better known as 36. Love the cubic pattern because once you use it, you are done. There's never further factoring once you use the cubic pattern. All right, let's look at 6a. Top of the flowchart again. Is there a common factor? Well, there better be. Are you looking at the wrong question? 6a. Yeah, there's a common factor of 6. Anything else? X. Good. So we're going to factor out the 6x. And that leaves us with x to the second. Good. Minus 9. And what I just wrote down in red is a two-term difference of Squares, very good. So that x squared minus 9 factors into x plus 3 times x minus 3. And what would be wrong if that was my final answer? Yeah, that 6x you guys factored out is another factor. It needs to stay out in front. So that was one of those 2-level factoring questions. You got to take out the common term and then factor some more. And then 7a, moved on to 7a. There's no common factor, but I do notice I have 4 terms. What's the technique we utilize for 4 terms? Grouping. So first group and second group are going to have their own little common factors. Let's see. Common factor of the first group? And when you take out a 3x squared, and you could literally divide 3x squared underneath each of them if that helps you simplify, but we end up with 1x plus 4. And then same issue here, I need to take out a common factor. Remember, the goal is you have to take something out, and you need the parentheses to match when you're done. So common factor of 5, which means positive 5, so we write down positive 5. Look at that. We're left with x plus 4 if you divide by 5. All right, so now in the question, you have 2 terms technically. This is a term and this is a term. But within those 2 terms, there is a common term, it's written in green, of x plus 4. So that x plus 4 comes out in front of the whole problem. We're factoring it out, so it's gone. But what is still there? Good, 3x squared plus 5. And I'm a little paranoid because of that worksheet we did where like there was factoring and then there was more factoring and then there was more factoring. Is this one of those questions where there's another level of factoring? No, the pattern that you're always watching out for is the difference of 2 squares. So when I look at my blue factor here, well, it's not even a difference question, guys, so it's not going to factor again. But what would be, I will warn you, you guys might want to try 6b. It's a good time. It's one of those ones where like you factor, and then you factor, and then you factor again, right? Did you see this, the follow-up factoring question? It's a good time. All right, inverses. First question on the inverse section, I'm going to ask you to switch to the x and y, because you're going to find the inverse by turning the function inside out. Now, at first glance, let's do AA. F of x is just a really fancy way of us saying y. So when I ask you to turn the function inside out, you're going to rewrite it as x equals 4y minus 9. And the answer I want in, of course, function notation, I already named it F inverse for you. Your job is to isolate for the y. So think about some algebra here, guys. You're going to need to add the 9 over. So you have x plus 9 equals 4y. And then your last step is going to be divide everybody by a 4. Now, if you could please think about dividing every term individually by a 4. And then, of course, the function's backwards because of the way we solved it, so you got to pick it up and turn it around. X over 4 is 1/4 x plus 9 over 4. (8b) is real similar. At some point in your math on 8b, you have to get rid of a coefficient of 1/2. What's the easiest way to get rid of a 1/2 coefficient? Multiply by the reciprocal, which is 2. Good. Make sure that gets distributed, though. Oh, boy. This question on the test is not going to look like this. But if you understand all these concepts, you'll be fine. What's going to happen on the test is I'm going to give you a bunch of statements. And it's going to say, check all that are true. Now, when I say something like check all that are true, is it possible that none of them are true? Yes, but not likely. Is it possible that there's just one answer that's true? Could there be like 2, 3, 4? Could all of them be true? I suppose, but not likely. So don't just check all the bubbles thinking you're going to get any sort of points, because be careful. All right, some properties of inverses. What happens to domain and range when you look at the inverse in the original function? Aha! Well, think of it this way. When you find an inverse, you switch the x and y. So what do you think is true about their domain and range? They're also switched. Yes, domain and range switched. That's what I'm looking for. And the reason domain and range are switched is because the x and y are switched. Oh, the dreaded sometimes, always, or never question. I hate these. A function and its inverse are the same. Sometimes is the right answer. We did a nice example. There's 3 different original functions graphed in our notes. And the first one, I forget if I'm saying this wrong. I think the first one was not a function, but the inverse was a function. The second one was the reverse, where the original was a function, but the inverse is not. And then the third one we did was they were both functions. So that's a sometimes. Oh, that's not even the question. Back up. Back up. They're not asking that. I'm leading into another question. The answer is sometimes, but I explained it stupid. So let's back up a minute. A function and its inverse are the same. I just want to make sure I'm explaining it right. The answer is going to be sometimes, so don't panic. Do you remember some problems on your homework where you found the inverse and you're like, oh, snap, it's the same function? Okay, that's sometimes. Did that always happen, though? Did you always find the inverse and end up with the same exact question? No. Like, case in point, that guy right there, the original and the inverse are nothing like. Okay? So the answer was still sometimes. Sorry about that. Getting excited about my notes that I did for you, but never mind. All right, can you have a function whose inverse is not a function? This is what I was trying to get at. Can you have a function who doesn't have an inverse function? Yes. I think it's coming up here. If the original passes the blank, then the inverse is a function. Vertical line test tells you if the original is a function. That's the one. So these questions kind of go together. The answer here was yes, and it has to pass the horizontal line test in order for the inverse to be a function. So if I go back to number 3, the case where you have a function who does not have an inverse function, that's because the original guy failed the horizontal line test. The original and the inverses are reflections across the line. Very good. Y equals x is usually how we say it, but what you said was not wrong. The identity function. All right, so know all of those ideas. And you're going to be checking possibly multiple bubbles when you get there. All right, hey, good news. Video's done.